Let's dive right in. Today we're going to make a procedural texture that will allow us to create a simple rectangular gradient on a plane. I'll also show how you can use this texture to animate deposition of a thin film, followed by evaporation of metal contacts, an industry academic standard procedure in semiconductor device fabrication. I've added timestamps in the description. As an extra bonus, I'll showcase a simple node network for building bottom gate, bottom contact thin film transistor devices, which I will make available for people to explore. Today, we're going to start simple by simply grabbing and deleting the default cube with X, hitting Shift-A, adding in a plane, hitting Z and coming to our material preview, and from there going to Edit, Preferences, Add-ons, and making sure we have the box for Node Wrangler checked. From there, I'm going to exit out of this, open a new window, change to a shader editor, hit N to close the side panel, and with our plane selected, hit New to add in a new material. With our material in place, I'm going to move over just a little bit, hit Shift-A, come to Input, and look for a texture coordinate. If at any point you're having a hard time finding a specific node, simply come to the search and look for what you want. In this case, texture coordinate. I'll go ahead, click this, and with Node Wrangler enabled, I'm going to hit Control, Shift, and then left click, and we'll see what that's going to do to our plane. Individually, it's going to allow us to visualize every set of coordinates here, and these are essentially all different object or coordinate systems relative to this plane. We're going to be working with object coordinates today, but for a more comprehensive description of what each one does, there's a fantastic video from Aaron Dale's channel that I will link in the description. If you can't see the outputs, simply come over to your preview window or main window, hit Z, and make sure that you actually are in Material Preview, because if you're in Solid View or Wireframe, you won't be able to see this. So coming back to Material Preview, grabbing our plane, we're going to start right away by grabbing our texture coordinate, moving it over just a little bit, and we're going to go ahead, hit Shift-A, add in a converter, and separate XYZ. Now, as soon as I add this in and connect the object coordinates to the vector output, you'll see I've got a difference for X, Y, and Z is going to give completely black because this is a plane with no Z dimension at the moment. What this is going to allow us to do, though, is isolate each of these sets of coordinates and work with each one. So from here, I'm going to go Shift-A, add in a converter, math, and I'll connect the X into the top value and change from add to compare. Now you might notice this fine white line here, that is sitting at 0.5. We're going to change the value, or the second value, to 0, and the line has now moved. We can also grab this epsilon value, so I'm going to hold down Shift and just slide along here with my left mouse button, and this is going to give us our rectangular gradient in the X direction. Very simply, to get the same effect for the Y direction, we're going to select our compare node, hit Shift-D to duplicate it, and connect in the Y value. So you can see we already have a value of 0 here and an epsilon of 0.9. If we visualize this with Control, Shift, and left click, we can now see the other part of our gradient. Now, one thing to note here is that essentially what we have is a series of black and white values, and black is going to be taken by Blender to mean 0, and white is going to mean 1. So if we do simple math on those values, we can create various different patterns, and that is the underlying idea of procedural textures. So I'm going to go ahead, Shift-A, Converter, Math, and this time we're going to change it to a multiply. So now, when we multiply the X values by the Y values, anywhere that is black, namely here for the X and here for the Y, will be black everywhere on the multiply output. And this has given us our boundary. Very simply now, we can adjust each part using the epsilons for the Y. We can use the epsilons for the X, or the X and the Y rather, and we can change the value offset to move this wherever we'd like. Before we go any further, a worthwhile tip is discussing how to get circles. So for circles, we're just going to move our texture coordinate back very quickly. I'm going to go Shift-A, come in, grab a converter, vector math, and this I'm going to set to multiply. We'll put it in the top coordinate here for the object, and we'll change all of these values to 1 for start. Just so that you're clear on how I did that, I left-clicked on the top value and dragged down, and that let me edit all of them at once. Then I'm going to add another vector math, but this time I'm going to change it to distance. I'll plug the top coordinate in here, and now I have a fine-ish circle, and I can use the vector math values to sort of change the dimensions of it. We're going to keep it at 1 for now. If I do the same thing where I add in a compare value and put the value of the distance into the top, now I have a circular gradient around my periphery, and I could use this as I wanted to. I could also change the aspect ratio using the vector multiply. All of these examples lead to a key point. A significant amount of working with procedural textures is about creating these black and white masks, because they're going to let us control other things. We'll expand on that later, but for now we're going to work on adding some visual interest to our rectangular border. So right now our border is quite linear, but we can add a little bit of randomness or interest to it by manipulating the original set of coordinates here. So I'm going to move the texture coordinate out to the side, Shift A, add in a texture, noise texture, and I'll input the object coordinate into the vector for this texture. One thing worth noting about Blender is that vector and color can be used somewhat interchangeably. Both take in and output 3 values. So for vector, that would be X, Y, and Z. For color, it might be R, G, and B, or it might be HSV. In either case, you can connect vector into vector and you connect color into vector as well. So what I'm going to do with that is I'm simply going to Shift A, add in a color, mix RGB, and I'll start by adding the object coordinate directly into the top socket, color 1. I'll add the noise texture into the bottom socket, color 2, and I'll use this to output and control the overall vector. One thing that I'd like to do here is change the option from mixed to linear light. You can see that's had a very dramatic impact. For a full description of what each of these modes does, again, Arendelle has a fantastic tutorial, but for our purposes right now, all we need is to know that we're using linear light. We can then adjust this factor to control how much our border is impacted by that noise. So we can bring the noise all the way up, and now we're looking pretty much exclusively at the output of the object coordinates into the noise, or we can bring it all the way down to get our original nice border. Of course, what we can do as well is choose an intermediate value and then adjust some of the aspects of the noise, such as the scale, the detail, or the roughness. And of course, we're not limited to just noise textures. If you're interested in a series of others, we can explore, for instance, texture Voronoi. I quite like Voronoi for using the color output here, and then if you change the randomness all the way down to 1 and bring the scale very high, you can get this interesting pixelated output. You can also use a wave texture, and if you bring the object coordinate down and bring the color into output 2 and apply some amount of distortion, you can get this sort of interesting swirling pattern around the periphery. For today, we're going to be working exclusively with a noise texture. One thing worth noting here is, as I mentioned before, with these circles, you can add in a converter vector math between the object and the noise texture. And if we use multiply, this will let us actually control the noise in the 2 separate directions. So we'll bring the scale down a little bit to showcase this. And now I could make the X effect much stronger. So you can see there's a smearing on the band here, or I can make the Y much stronger. So we'll do that same way, and now we have a smearing in the opposite direction. And this is just an extra set of controls for anyone who's interested in using those. For most purposes, you're going to be all right with just manipulating the individual values for the noise texture. And of course, changing the offset and the blending. Now at this point, we've started to build up quite the nice simple node network, but the key thing is that it's outputting a single value. What we would like to do is perhaps bundle all of this together so that we can control everything and hand this off to someone else who is perhaps less familiar with nodes. To start, I'm going to show how you can simply input values and use them to control and why you might want to do that. I'm going to go ahead, hit Shift A, input, add a value, and now you can see I can actually just connect this value directly in here. So for the epsilon, we'll start by copying what it's already at, 0.87, and we'll duplicate this. We can also rename these nodes for clarity. I'm going to hit F2, rename this, and call this X epsilon, or X eps, and we'll use this one, and this will be the Y eps. And now I can simply connect this directly into the epsilon and directly into the epsilon here, and I can use this value to control the effect. The reason that I might want to do this is because when I have several of these things in one node, I can bring all of these off to the far side, and now all of my controls are nicely labeled and accessible. Similarly, I can add in a few more values, so input, value, and this time we're going to use it for the factor in the mix. So I'll go ahead, put this in, and we'll put this directly into the factor. I'll call this one gradient texture, which is not entirely accurate. Gradient textures are their own beasts, texture, but it's going to work for our purpose, and we can use this to control the extent of mixing. Now, when we go ahead, we're going to move all of these out to the side. I'm going to simply drag a box over everything that I'd like to include here, make sure all of these nodes are selected, and then I'm going to hit Control G. You can see that the screen has now turned green, and I have this little group input selection and a group output. If I come up to the top here and click this little arrow, you can see what I've done is I've taken any value that was outside and created a node group that is now controlling these values. So I can unplug each of these and use these as individual sliders. We'll delete all of these values, In fact, we'll keep them for now because they're going to have one useful effect, which is when I open this node screen again, if I drag over here and I'd like to rename these, I can simply select my input, hit N for the side panel, come up to group, and now I can actually label these as well explicitly. So we'll call this X EPS, Y EPS, Y EPS, Y EPS, and of course our gradient mix, which is a better name for that, gradient mix. At this point, we could also add in other options. So I'll add in the noise scale, the noise detail, and the noise roughness. And if I wanted to access the noise individually in each axis, what I could do is I could Shift A, add in a converter, combine XYZ, set the Z to 1, and I'll set both of these to 1 to start as well, and plug this factor in. So I could now control the X noise and the Y noise. And of course, I can label everything. So we'll do that, noise scale, and I'll just speed through this part. With all of that in hand, we can simply close this off. We'll delete these 3 values over here because our node group is now controlling everything, and we can rename our node group as well. So we'll call this our gradient. There it is, our rectangular gradient. It has nice little inputs, so you could control each of these through separate values or other math if you wanted to. And all it's doing is outputting a very simple value for us that is giving us a black and white mask. As I said before, black and white patterns are extremely useful. And at the simplest level, we are going to use this to tell Blender to go either between 0 and 1. To showcase this, I'm simply going to add in a mixed shader. So with the principled BSDF I have here, I'll set the base color to blue, Shift D to duplicate this and change it to orange. And now I'll add in a mixed shader. So Shift A, shader, mixed, and I'll plug the blue into the top and the orange into the bottom. Now, if I go ahead and show what this conveys, on a perfect mix, it's showing 50-50. If I go all the way to 0, it's going to show the 0 value or top, blue. And if I go all the way to 1, it'll show the orange. If I have some distribution of 0 and 1, or black and white, I can plug that directly into the factor and use that to influence where each of these appear. I can also use this to control any of these 0 to 1 values in the individual shaders. So I could make certain areas metallic, shinier, transmissive, or if you set up for alpha, you can actually make them completely transparent. And I'm going to show that now because that one is particularly worthwhile. So we'll hide our mixed shader briefly, or rather we'll just connect the blue directly. And then what we're going to do is we're going to come and go to settings here. In cycles, this works immediately, but for Eevee, we have to do a little bit of extra work. So we'll enable screen space reflections under our render properties tab. We'll also enable refraction. Come down to the materials tab, scroll all the way to the bottom, and we're very simply going to enable a blend mode of alpha blend. We'll uncheck show backface. And then we're going to take our black and white rectangular mask value, and we'll input it directly into the alpha. And what this is going to do now is it's going to give an alpha value of 0, or fully transmissive, where it's black, and white will show off the blue area, which is our base texture. So I could put anything underneath this, and you'd be able to see it. A very simple and very clean masking effect. Of course, you can also use black and white images that you already have as masks. And that can be a very useful way to transfer real data, such as atomic force microscopy images or TEM images, into meaningful objects or scenes in Blender. Of course, images have finite resolutions, and that is one of the main advantages of a procedural texture, is essentially it's mathematics, so you can achieve infinite resolution and customize in all kinds of ways. At this point, we've covered the keys concept. Procedural nodes can be customized to create patterns that we can use to mask different areas. We can also clean up the nodes and make them more accessible for other users. We're going to now return to our rectangular gradient, and we're going to add in a feature for animating thin film formation. What we'd like to do is basically combine a noise texture on top of our existing gradient and then use all of those inputs to animate. Because our rectangular gradient is simply outputting a black and white value, all we really need to do is output another black and white value over top of the white area, and that's going to let us control what appears and when. Very simply, I'm going to Shift A, add in a texture, noise texture, and this time we're going to add in a converter, color ramp, connect the factor, or connect the color into the factor, change to a constant interpolation, and now I'll drag this out, and if we show what this is showing, you can see we have a noise texture here. We'll bring this up a little bit, maybe to 15. Again, I'm going to go with a higher detail of 3 and a roughness closer to 0.75. And now, because this is its own black and white pattern, once again, very simply, Shift-A, Converter, Math, we'll multiply the color input here and the output of our gradient. And when we show off the result of this multiplication, we now have our nice rectangular gradient and we have a noise texture in the middle that we can control with this little slider right here. To provide a little bit of technical insight here, why would we want to do this? Well, whenever you're evaporating some sort of organic material or other material onto a thin film, often you'll have some sort of mask that the substrate will sit on. So if this were a simple glass slide, you might have a metal periphery that holds it in place. You wouldn't expect to see anything evaporate in that area, but you'd like to be able to show it evaporating onto the actual target place. So we're actually going to bring this noise roughness down by bringing the mix down, because I'd like it to actually be a bit of a tighter gradient. You shouldn't have a gradient that's that messy. Something a little bit more like this would be appropriate, and now we can actually animate this interior region to show the appearance of the film. How are we going to do that? With a mixed shader. So I'm simply going to actually shift to cycles for starters, just so that we can do this a little bit more quickly and with glass. And now I'm going to make our top shader here essentially a simple glass shader. So I'll bring the saturation all the way down, I'll bring the transmission all the way up, change the roughness to about 0.2, and this will be our glass. Then we'll deposit something along the lines of pentacene, which is this lovely blue color. And when we use this factor, or this multiply output to control the mixed shader factor, we see what we have. You can see we have this outer surface that is glass, not super visible at the moment, but that's just because our scene doesn't have exactly great lighting. So I'll make this a bit bigger. Now you can see we have a thin film, and we're going to very, very simply add in a solidify here just to give it a little bit of depth. So there we go, we have a glass slide and we have what we would like to deposit on top, namely pentacene, within this shadow masked area. And all we're going to do to achieve that effect is move this over. So this is actually going to be our animation. I'm going to start off by having nothing present at all. On frame 1, we'll right-click on the position here to insert a keyframe, jump ahead the number of frames that we'd like to go, let's say 24 frames, so that this will happen in 1 second over 24 frames a second. And now I can bring this value down until my film is completely formed without any gaps. Something like this would be just fine. Insert a keyframe here, and when we go back, now if we press play on the timeline, you can see our film animates in. If we do this in material preview so that we can watch everything in real time, we'll just wait for the shaders to compile very quickly, and then same idea, press play, film animates in beautifully. And just like that, we have a very simple thin film animation. We've respected our substrate boundary. We have the color appearing where it should. And now we're going to use a very, very similar trick, this time with the alpha values, to show the evaporation of the metal contacts appearing on the surface. Now, you could, of course, model this in and then do all kinds of materials trickery, in much the way that we have. But for some things, it is actually just easier to work with something simple. So I'll add in a simple plane, shift that down. I'm going to bring it up just the tiniest bit by hitting G and Z. And we'll use contacts today that would be similar to what you would see in a transistor. So tab into edit mode, Control R for loop cuts. I'm going to roll up on my mouse wheel to add 2 of them, left click to drop them in place, right click to make sure they stay there, then S and Y so I can move them a little bit closer. I'll hit 2 for edge select to grab this leading edge here, hit E and X to extrude in that direction, add another loop cut with Control R and drag it all the way out here, then left click to drop it in place. Once again, hitting 2 for edge select, I'll grab this edge and this edge right here, hit E to extrude, just move away, then right click to drop those, S and Y so that I can scale them out like this. And this would be essentially a transistor contact pad. You'd make electrical contact here, and the work of the device would be happening right around here. Now, the key thing that I need to do here is add a little bit of thickness with a solidify, so we'll do that. There it is, and it's now intersecting our film. Perfect. We're going to add a slight bevel so that it looks a little bit more clean. We'll bring this value down quite a bit, and we'll change these segments up to about 3. Right-click to shade smooth. And now the thing that I'd like to do is tab into edit mode, hit A to select everything, G and X to move it here. You'll notice that the object origin is staying right there. That's very important because I'm going to set up a simple mirror modifier, mirroring across the x-axis. So now I have our channel. So these would be our contacts. This is our channel width. And of course, we can change this by simply tabbing into edit mode again, hitting G and X and bringing those closer if we wanted to. And these would be our two contacts, so our source and our drain, if that's how you would like to think of it. G and Y to bring those down, and I'll add in a simple array modifier, change the Y factor to about 2, the X to 0, and now I can add in a good number of contacts. So for these, to make them animate in and out, we're going to use a very, very similar trick. We'll come to Materials, add a new material, and this time I'm going to use a metal gold contact. So very simply, a yellow color, metallic, bring the roughness down to about 0.2. I would like some slightly better lighting in the scene, so we're going to come up to this little box, hit Scene World, and now I can actually use some of the default lighting. So this will be our default lighting. This would be the same as in Material Preview, in fact. And now I'm going to go ahead, grab these, scroll out until I can find my material, and this time we're going to animate this alpha value. So if we were working in Eevee, you would still have to come down for this material and enable the alpha blend setting. Because we're going to work in cycles, it's going to work right away. So go ahead, change back to cycles. Shift A, add in a texture, noise texture. We're going to add in a converter, color ramp again, color into the factor, change to a constant interpolation so that we're only dealing with black and white values. We'll bring the scale up to about 15. I already know I'm going to want slightly higher roughness and detail, and we'll use this and plug this right into the alpha value. So you can see it looks as though it's evaporating. Now, if we were to zoom in very closely, what you'll notice is it's actually wrapping around the whole thing instead of building up from the bottom. We could add that, but for our purposes in this animation, you won't be able to tell from the distance that we're actually looking at. So I'm very simply going to bring this all the way out to here so that you can't see anything. And we'll start this at about 24 frames. So once our film is deposited, we can deposit our contacts. I'll right-click, add a keyframe here. Go ahead 48 to frame 48 rather, so another 24 frames. Drag this down until our contacts appear. Right about here should be good. We'll insert a keyframe, and now we can watch our whole animation. So there we go. Blue film, and the contacts drag in. You might notice that this is occurring a little bit quickly. If that is sort of your impression of it, you might want to change the scale to be a little bit lower. I find that a lower value will actually change this. You may have to also correct the values in the color ramp after the fact, so bring it all the way down just to make sure that everything is changing the way that you want it to. And so we'll go ahead and actually set this up to work with Eevee so that you can see everything. So we'll come down, go to the blend mode, alpha blend, make sure we uncheck show backface, but we will enable, in fact, we don't need screen space reflection because we're not actually working with glass, so this should be just fine. And let's watch the whole thing. Here's our glass substrate. We're going to go ahead, press play. Our blue film appears, and then our contacts appear right after. If we deselect the contacts and then watch that again, there they are. And so just like that, we've used very, very little geometry. In fact, almost everything right now is in these contacts. So if I hide the contacts, you'll see we have a plane that is all of 12 vertices and a few faces. We bring back the other one, and now we have pretty much nothing. In fact, it's not even 12 vertices because there's a background plane in here. So if we hide everything except our original plane, all we have is 8 verts. We have this nice animation that we've achieved for thin film deposition. Finally, I'll show off an animation I made using a OTFT or organic thin film transistor node, which was essentially a custom shader for making bottom contact bottom gate transistors. It's a more elaborate setup, but it allows me to use a very, very simple plane with minimal geometry to simply go ahead and create all of the respective layers and then illuminate them to show the passage of charge transport. This would be a very nice figure to include in a presentation, but it could also be used in a sort of more static state for an actual paper figure. I will be making this node available to anyone who is interested in exploring it a little bit in their own work. It is quite a bit more involved, so if we actually come back to Blender and see this is the node that's being used to create it, if I scrub the timeline, it's creating all of these aspects and changing the values. It lets you put in whatever materials you want for each individual component, and then you can adjust all of the values on the fly to your liking. Like I said, it is quite a bit more involved, so when you open it up, you can see there's all kinds of things going on, but this is essentially the gist of what I wanted to put out. I won't pretend that these types of nodes are easy to make if you're just getting started, and mine are far from perfect. I will be making this available for people to explore as they like. But if you have the time to invest in learning procedural textures and geometry, it will not only let you control these things for yourself, but it can be useful to build incredible resources for your own use later down the road, or for other people, be they beginners, enthusiasts, or experts. I love procedural approaches, and I really think that they are more than worthwhile. For other fantastic resources focused on procedural textures and more generally on workflows, I strongly recommend both Arendale's channel and the Default Cube or CG Matter channels. The Arendale channel happens to have all kinds of videos detailing many of the aspects of what's going on behind the scenes and more nitty-gritty looks at the math and getting started with all kinds of aspects of procedural textures. The Default Cube CG Matter channels often use many of these to achieve very specific effects, and I've referenced these in tutorials before. Both are fantastic, and I really can't recommend them enough. If you have other favorite channels that focus on procedural materials or workflows, please let me know them in the comments. One fun note to end on is the fact that I've learned more about how to use mathematics while playing with nodes than I ever did while studying math itself, and it can be quite a lot of fun. In any event, expect more procedural workflows in the future, as well as an increasing number of pre-built textures and geometry node systems for scientific topics. Next on the roster is making molecules in different styles using Blender, and that has me hard at work. With that, thanks for coming out. My sincere thanks to the supporters on Patreon who helped make this possible. If you found this video useful or engaging, consider subscribing and sharing it with your friends and colleagues. Happy figure making, and until next time, you have yourselves a great old day.